So we're going to start by talking about multiplication of monomials. So we'll define this idea of a monomial just real quick here. When I say monomial, I just mean a single term. Something like a 3x squared or a 4ab cubed. A single term, that's a monomial. So let's talk about how we multiply monomials. I need to pull out my links. When multiplying monomials, the first thing we do is we multiply the coefficients. So in those two examples that I gave up there, that would be like the 3 and the 4. So if I wanted to multiply those two together, I'd start by multiplying the 3 and the 4 together. When I multiply the variable parts, I have to then use what's called the product rule. So you multiply the coefficients, and then you use the product rule for the exponents. And the product rule, which I have written here below, says that when multiplying exponential expressions with the same base, we add the exponents. So anytime you have something like b to the m times b to the n, it's b to the m plus n. So like in the example right here, b to the fourth times b to the third should be what?
B to the 3.
B to the, what'd you say? 7? Right, because you're adding 4 plus 3. And why is that true? Well, just think about what b to the fourth means. B to the fourth means b times b times b times b, right? And b to the third means b times b times b. If you multiply all of those together, how many b's do you have? 7. So that's why we add exponents. So real quickly, again, using the rule that you multiply coefficients together, and then all of the like bases you're going to put together and add the exponents. What would be the product of 6x to the fourth y squared times 3x to the seventh y?
18.
You get 18 from multiplying the 3 and the 6 together.
X to the 11.
Multiply the x's together, you get x to the fourth times x to the seventh, which is x to the
28. 28. Right.
what did I say up here?
You add
Add, so 4 plus 7,
11.
11. Okay, and then y squared times y.
Y cubed.
Y cubed. Because remember that if there is no exponent, what is it understood to be? 1, right? So I'm going to take y squared times y to the first, and I get y cubed. So the product of 6x to the fourth y squared times 3x to the seventh y is 18 x to the 11th y cubed. That's the product rule. Multiply like bases, you add the exponents. Okay, now the power rule. What happens if we're going to take one exponential expression and raise it to another power? That's called the power rule. So when it's raised to a power, in that case is when you multiply. So when I say raised to a power, I mean take something like b to the m here and raise it to the nth power. That's going to be b to the m times n. Power to a power, you multiply. Like bases multiplied together, you add. Power to a power, you multiply. So b squared times b to the, b squared raised to the fourth would be what?
B to the 8.
B to the eighth. Now let's explain why. What's b squared actually mean? It means b times b, right? And if I do that to the fourth, I get a b times b 4 times. 1, 2, 3, 4. But how many b's are actually there? 8. So you can see why you multiply in this case, but you add in the other case. All right. So, x to the fifth raised to the sixth.
X to the 30th.
It is a power raised to another power, so x to the 30th. Very good. So it's real easy when there's just one factor inside. This second one here is a little bit of a curveball. Minus 4x squared y cubed, all to the third power. We're going to multiply that times negative 3y.
Do your exponent first.
So you got to do the exponent first, so we've got to take care of this cube. Now, what you've got to notice then is that if you raise multiple things to a power, you have to apply that power to everything inside. It raises every factor to that power. So this looks like, I'm just going to write the negative 3y and leave it hanging out. But you have the negative 4 raised to the third. You have the x squared raised to the third. And you have y cubed raised to the third. And I think it's helpful to go ahead and write it out. And then we can take each one of those individually. I'm going to keep the negative 3y just out front. What is negative 4 raised to the third power? It's negative 4 times negative 4 times negative 4.
No.
4 times 4 is 16. 16 times 4 is
64.
64. Is it positive or negative?
Positive.
Negative.
Oh, yeah.
Why is it negative?
Because once you multiply 4 by 4, negative 4 by itself, it becomes a positive, but still got multiplied.
You got one more negative after that, exactly. So 3 negatives, any odd number of negatives is going to be negative, because even numbers of them drop out and become positive. What's x squared to the third?
X to the 6.
X to the sixth, because it's multiply. And what's y cubed, or y to the third to the third?
Y to the 9.
Now let's multiply all of this here times negative 3y. So negative 3 times negative 64. I'm going to have to scribble that off to the side here. 64 times 3 is 2, carry your 1. So 192. Is it's positive, because a negative times a negative is positive. X to the 6th. Y to what?
The 10th.
10th. Because we add when we're multiplying. Add exponents.
Does it matter what order you put it in?
It doesn't mathematically matter. It's common practice, kind of convention to do it alphabetically, so X then Y. But it's not wrong if you do Y to the 10th, X to the 6th. I don't think the online homework counts it wrong. I certainly won't on the tests. Okay. So that's all that's it from 10.2. 10.2 is just being able to multiply like bases to add their exponents and raising power to a power. Okay. And you just got to remember that you multiply the coefficients and then you multiply all the like bases together. So to cover the rest of the exponents rules, we're going to jump ahead to 10.4 and talk about dividing and talk about negative exponents and the zero exponent rule. Okay? So the quotient rule, we talked about the product rule. The product rule says if you multiply like bases, you add them. The quotient rule says that if you've got the same base, and you're dividing them, right? Key word here is dividing. Then you subtract. You subtract the exponent in the denominator from the exponent in the numerator. Or, equivalently, you can subtract the smaller exponent from the larger exponent and leave the answer on the end of the fraction with the larger exponent. So the key is you can subtract. You can subtract the top minus the bottom minus the top. If the top one is smaller than the bottom one, then subtracting the top minus the bottom will give you a negative. Okay? We'll talk about negative exponents in a little bit, but it's actually better it gives you a cleaner answer. You don't have to worry about negative exponents if you always take the larger exponent minus the smaller exponent, but leave it on the end of the fraction that has the larger. So like this one down here, this b to the third over b to the seventh over b to the third would look like b to the fourth, because 7 minus 3 is 4. But if I write it out, you can see why. If I put 7 of them on top and 3 of them on bottom,
Take out 3.
notice how 3 of them end up canceling.
There's nothing on the bottom.
And so there's nothing on the bottom. When everything cancels by division, you end up with a 1 left behind. So this is like 4 of these b's, b to the fourth over 1, which is just b to the fourth. So notice I took the larger minus the smaller. If this had been upside down, like problem B down below, you'll see you just leave it on the end with the larger number. So what's b to the 15th over b to the third?
B to the 12.
15 minus 3, 12, and it's on top. And if it's on top, I don't have to write anything on bottom. B to the 3 over b to the 15 if it's upside down.
1 over b to the 12.
Take the larger minus the smaller. 15 minus 30 is 12, so b to the 12th. And if nothing's left on top, put a 1. Okay. All right, so let's look at C here. 27 x to the 14th y to the 8th over 3 x to the 3rd y to the 5th. So we'll do numbers, x's, and then y's. What's 27 divided by 3?
9.
9. 3 out of both of them leaves a 9 on top, right? What about x to the 3rd and x to the 14th?
X to the 11th.
On top or bottom?
Top.
Okay. And y to the 8th over y to the 5th?
Y to the 3rd.
On top or bottom?
Top. Sorry, I didn't mean to talk about that.
That would be all over 1 since everything was gone from the bottom, which I could just write as 9x to the 11th, y to the 3rd. All right, let's try D. Start with the 4 and the 8.
1/2.
You can take a 4 out of both of them, right? When they're just numbers, you're dividing. You're not subtracting any exponents or anything. So if I divide a 4 out of 4, you get a 1, and a 4 out of 8, you get a 2. So I know I've got a 1 up here and a 2 down here. Okay, so with the x's,
Just X on top.
3 minus 2 is 1. The big one's on top, so right. X to the 1st on top. So you don't have to write the 1. I just did just so that you can see it in your notes. I'm going to rewrite the answer in just a second. Y to the 7th over y to the 10.
Y to the 3rd on bottom.
10 minus 7 is 3, and it goes on top or bottom.
Bottom.
Z to the 8 over z to the 8th. You get a z to the 0 if you subtract, but you also can just recognize the fact that anything divided by itself is 1, right? So they just cancel out. So what you're left with is an x over 2y to the 3rd. Kind of a good point here. I'm going to make a little note here. This is not part of the answer, but just let me make a little notation here. Z to the 8th over z to the 8th. we know has to equal 1, right? Because it's a number divided by itself. But if I use my subtract rule, it also has to equal z to the 0, right? So what that tells me is z to the 0 has to always be 1. Anything raised to the 0 power is going to be 1, and this is the reason right here, because it's the same thing as subtracting all of the exponents away, and you're left with none of that, but dividing by itself is the same thing as 1. So, if b is any real number other than 0, then b to the 0 is 1. So, why? Well, consider the example. That's b to the 4 minus 4, which is b to the 0. But we also know it's equal to 1, because you divide by itself. Okay, so what is 8 to the 0?
1.
Because anything to the 0 power is 1. What's negative 5 to the 0?
1.
Now what's negative 7 to the 0? Now there's a difference between B and C.
It'd be negative 1.
Do you see that the B example has parentheses? This one doesn't. Does that make a difference? If we think of the minus sign as a multiplication, and you go back to PEMDAS, notice how I've got right here is a multiplication, and right there is an exponent. The 0 only applies to the 7. It does not apply to the minus. On number 5, on letter B, where we've got the negative 5, the 0 applies to both the minus and the 5 because of the parentheses. So according to PEMDAS, what do I do first? E or M?
E.
E, right? Right there. So you have a minus, and then you take this thing right here. 7 to the 0 is 1. And you then still have a minus sign. So if you have a minus sign sitting in front of a number raised to a 0 power, you have to decide, is the minus sign being raised to the 0 or not? The only time it is if it's in parentheses. Otherwise it's not, which means it just stays. So that answer is negative 1. The next example should kind of drive this home. Right? X to the 0
It's 10.
is, x to the 0 part of that is 1, but the 10 doesn't have an exponent of 0. Right? So this would be 10 times 1, or just 10. But what about E?
It's 1.
Everything raised to the 0 to the 1, everything raised to the 0 power is 1. And F,
1.
even if the thing inside that parenthesis is a big nasty thing, you raise it to the 0 power, it's still 1. Have you guys seen that before? That's the quadratic formula. Yep. We'll cover that later. All right. What about negative exponents? What does it mean to raise something to a negative power? So if I have any positive number and I raise it to a negative number, like here's a example up in the corner. You don't have to write this down, but I'll go ahead and give it to you. If I have b squared over b to the fourth,
I think it's
do you remember what that is by our previous rule? B squared over b to the fourth would be what?
B to the B squared.
Is it b squared?
1 over B squared.
It's 1 over b squared, right? Because you take the larger minus the smaller and keep it on the end with the larger. But I could also do b to the 2 minus 4 and get b to the negative 2. Right? I said either way it will work. This is the preferred answer, but this is also true, but that means those two have to be equal. So raising something to a negative power means take 1 over b to the positive power. So if it's b to the minus n, you're going to do 1 over b to the positive n. And also, if it's 1 over b to the minus n, it becomes b to the positive n. Here's what I think in my head. When I see a b to the minus n, I write it over 1 and I move it to the other end of the fraction. If I see a 1 over b to the minus n on bottom, I circle it and I move it to the other end of the fraction and make it positive. Okay? Negative exponents move from the numerator to the denominator or from the denominator to the numerator and become positive. So like 5 to the minus 2.
1 over 5 to the 2.
1 over 5 to the positive 2, right? I write it over 1 and I move it down. But actually I can go one step further when it's just a number. What's 5 squared?
25.
I can write that as 1 over 25. So 5 to the minus 2 means 1/25. Okay. So let's do 3x to the minus 6 y to the fourth. I want to write this expression with only positive exponents. So I got to break it up into all the different factors. Treat 3 x to the minus 6 and y to the fourth each separately. Okay? It's all going to be written over 1, and I want to take anything that has a negative exponent and move it to the other end. So I'm going to take this here and move it down here, but leave everything else behind. So this expression becomes
3y to the 4th, x to the 6th.
3y to the fourth on top, and on bottom, x to the 6th. Does that make sense? You're taking negative exponents and moving the other end. Okay? What would you move on this one?
Negative x. I mean x negative 8.
Do I move the 4 or not?
No.
Since it's not in parentheses, this 4 right here would have an understood 1 power, so it's positive. The 4 stays here. But this, I can move up here.
And the 7 you can move down.
Okay. So on top, I'll have x to the 8th. And on bottom,
4 to the 7th.
4,
I mean,
and then I have a 7 squared. By the way, what is 7 squared? It's 49, right? And then 4 times 49. Yeah. 196. Very good. So let's summarize all of the rules for exponents we have so far. We've got Multiplying like bases, which is the product rule, we've got the power to a power rule, we've got the quotient rule, we've got a zero rule, negative exponent rule. There's actually 7 total of them, a couple that I did not include that I'm going to have written down. Actually, he only writes down 6 of them, he being my colleague who wrote these notes. There's actually a 7th one that I'm going to include. So the first one says you add when you multiply like bases. That's the product rule. The second one is the quotient rule, so you subtract. The third is the power to a power rule. The fourth is the negative exponent rule. The fifth, and what I'm going to call 6th one, here's 5, I'm going to call 6, is when you have 2 things multiplied together inside of parentheses like this, and you raise it to a power, you raise each one of them separately to a power. That's also true if you have x to the m over x to the n raised to a p. That's x to the mp over x. Sorry, I should say y. Let me fix that. Y here. Y here. Y to the np. So not only can you multiply the exponents times 2 factors that are multiplied together inside, but also if you have a fraction like this, you can raise the numerator and the denominator both to the power p. And then the 7th rule for exponents is as long as x is not 0, anything raised to the 0 power is 1. Okay, so as you look down below at A, B, and C at the bottom of this page, like this one here, oops, this one down here, what I'm going to ask you to do in this section is be able to simplify these expressions that have exponents in them. Now, to be simplified, I want to make sure that 4 things are true. We're going to apply every rule we possibly can. So one of the rules is no parentheses appears. No powers are raised to other powers, so we apply the power to a power rule if we can. Each base only occurs once. And we've got no negative or 0 exponents. So when you look at this one, we want to simplify this. What's the first rule you see that we can apply? This one right here? The 2? So that's rule. Which rule will I use to do something with this 2?
5.
Number 5. Number 5 means I can raise everything inside to that 2. So what this ends up looking like is a negative 3x to the minus 6y, and then a negative 2 squared, an x to the 8th squared, and a y to the 4th squared. By the way, I could have done that right here. In fact, I'm going to go ahead and do it. This expression in here, what can I do with this x to the minus 6th?
Put it over.
So this could be the same thing as negative 3y over x to the 6th. Just because I have a little bit of limited space in here, I'm going to do that in one step. I could do it in a separate step, but go ahead and do it now. get rid of those negative exponents. Okay, so on top, I've got a negative 3y. I've got this negative 2 squared, which is now 4. Negative 2 times negative 2. X to the 8th is going to be
X 16th. I mean X 16th.
x to the 16th, y to the 8th, and then x to the 6th on bottom. So let's multiply the numbers together. What's negative 3 times 4?
12. Negative 12.
Negative 12. We can take this y here. Actually, let's do the x's first. You got x to the 16th on top and x to the 6th on bottom.
X to the 10 on top.
16 minus 6 is 10, so x to the 10 on top. And I've got a y to the 1st on top times a y to the 8th on top, which would be y to the 9th. So the x's are gone, the y's are gone, I'm done. Negative 12, x to the 10th, y to the 9th.
What if I take the negative 3 down?
The negative 3 moving down would be wrong because the negative 3 is not raised to that negative 6, right? What is the exponent on that negative 3, right? A negative 3 without any exponent up there is understood to be a positive 1. So because it's positive, it stays where it is. Okay? So you've got to learn to think of the coefficient as separate from the variable. So that minus 6 is not included. And this negative out front here is a negative down on the base. It's the actual negative number. It's not a negative exponent. Does that help? Okay. All right, let's try this one. What would I do with this minus 3?
Raise it to the power.
You're going to raise everything to the minus 3 power. So you have, I'll write it out. You might could do this in your head, but x squared to the minus 3, y to the 5th to the minus 3, and 4 to the minus 3. So what's x squared to the minus 3?
Negative 6.
Power to a power is multiply. Yeah, so it's going to be 6, but it's going to be negative. Right? Because 2 times a negative 3 gives me a negative 6. It's when you have two of the same base side by side that you add. So using the same reasoning, y to the 5th to the negative 3rd.
Negative 15.
Negative 15 over 4 to the minus 3. Now what rule can we apply? It's number, I think I labeled it as 4 here.
4.
The negative exponent rule. Says I can move this down here, move this down here, and move this up top. Okay, so on top I'll have a 4 to the 3rd. On bottom I have an x to the 6th and a y to the 15th.
Would it be 84?
64, but yes, you can go ahead. When you got numbers raised to powers, go ahead and multiply them out. 4 times 4 times 4 is 64. (64) over x to the 6th, y to the 15th. All right, last one. Let's decide. What do we want to do first?
I'll make it.
You could take this square and apply it to everything inside,
No, I would rather.
or you could simplify inside and then square.
I'd rather simplify.
That actually is less work, but both give you the same answer, right? So what you could do is square every single thing inside and then simplify what's left, or you can simplify what's inside and then square everything that's left. So that's what I'm going to do. I'm going to do that second thing. All right, so let's look at the 3 and the 12.
1, 4.
I have a 4 down here, right? I can take this x squared here, move it up to the top. So I have an x squared, and now I have another x squared. Right? I just move that up here. So there was the x squared there, and then I moved the 1 up from the bottom. What about the y's?
Move it to the bottom. Y to the third.
Y to the third on bottom. And then the z's?
Just cancel out.
Just cancel. So this looks like x to the 4th over 4y cubed squared. Now you square everything. What's x to the 4th
X to the 8.
squared? 4 times 2 gives me 8. 4 squared is 16. Y to the 3rd squared is y to the 6th. There we go. Okay? All right. Questions about that one? Okay. So the last thing that I wanted to cover about exponents today is just a refresher of something you've probably done before. Maybe in a science class and not an algebra class. And it's writing down large or small, very large numbers or very small numbers without having to use all the zeros. It's called scientific notation. Have you guys seen scientific notation before? Vaguely recall that term. It's not very hard to work with. The main thing about scientific notation you got to remember is which way to move the decimal place. Okay? Scientific notation is just a way of writing really big numbers or really small numbers in a form that looks like this. A times 10 to a power. So a couple of examples. If I wrote down 2.037 times 10 to the minus 6, or if I wrote down negative 1.291 times 10 to the positive 8. Notice that the A in this case is always going to be some number that's bigger than 1. So it's never 0 point something. It's always 1 point something or bigger, but it's never bigger than 9.9999. It doesn't have 2 digits. There's always 1 digit to the left of the decimal place, and never more or less than that. And then it's times 10 to a power. Now 10 to the minus 6, just based on what we just learned about negative exponents, what's 10 to the minus 6? Ignore the 2.037 for a second. 1 over 10 to the 6th, right? So this number right here is like 1 over a million, right? 10 to the 6th is 1 with 6 zeros. Okay? This is very close to 0. Okay, so negative powers, sorry, you can't read that. Powers are very close to 0. Now, 10 to the 8th, on the other hand, is 1 with 8 zeros after it. It's 100 million. Okay? Okay, this is very far from 0. Because it's very big. So positive exponents are very far away from 0. Negative exponents are very close to 0. So if you see scientific notation with a negative exponent, think that's really small. Really tiny, really close to 0. If you see a scientific notation with a positive exponent, it means it's very far away from 0. It's big numbers. So negative exponents in scientific notation mean small. Positive exponents mean big. That's going to help you keep track of which way to remove your decimal place. So we want to be able to convert back and forth. So you see on your notes there, the first thing we're going to do is convert from decimal, like these numbers down here, A and B, into scientific notation. And in a minute, we're going to go back the other direction with numbers like these. Okay? So let me just fill in the blanks. This is real quick. You guys shouldn't have any trouble with this. Write the number in the form A times 10 to the nth. To determine A, move the decimal point on the number until the value is between 1 and 10. Basically means to the right of the first number. So like on this one, sorry, I'm recording, I got a point. So on this one, I'm going to put a decimal place right there. On this one, I'm going to put a decimal place right there. Okay, so to determine the n in your exponent, you've got to count. You count the number of places the decimal moved. If it moved to the left, it's positive. If your number was big to begin with, it's positive. If it moved to the right, it's negative. In other words, if your number was really small, then it's going to be a negative exponent. So like on this one, I'm going to have 5.21 times 10 to a power. Where did I get the 5.21? I put a decimal place right here. But how do I figure out what goes up in the exponent up here? You count places that you move. So from where the decimal starts, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's either 9 or negative 9. Since I moved it to the left, it's positive. Since the number was big to start with, it's a positive 9. There is the number in scientific notation. Okay, going the other way, I'm going to put the decimal place right here, so 6.893. This negative comes along with it, times 10 to what power? Is it 8? Negative, because the original number was small, and because you moved it to the right. All right, I know I'm out of time, but I can do this real quick. 2 blanks on this one are right or left. To convert from scientific notation to decimal notation, you move the decimal and fill in with zeros. So like on letter A, you take negative 2.6, and I'm going to take that decimal, I'm going to move it. Now I've got to either move it left or I've got to move it right.
Left.
Since it's positive, I'm going to move it this way. Right, this number up here. Don't pay attention to that. That negative just stays out front. It's the power that tells you which decimal direction to move. And since 9's positive, think big. I want to make more zeros to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Put zeros in here. And the way we do our notation in English is put commas every 3. So you have 2,600,000,000. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 3, and 3. Okay. On this one, 3.017. Which way am I going to move that decimal place?
To the left.
1, 2, 3, 4, 5, 6. Fill in with zeros. So 0.0000. There's your number. 0.5 zeros and then 3017. You can skip over page 6 in your notes. There's nothing in your homework over that page 6. So you have homework now from 10.2 and 10.4 together. The next set 13 in your homework is due on Friday, but that's all the stuff we covered today. Okay? All right. Well, we'll see you next time.